lecture. It might just take a bit of a while because it's just a long lecture. But in general, it's an easy lecture. This is just him again, taking some pride in statistics and why he chose statistics. Review exercise. This is where I saw actually that days is continuous. So average KFSH length of stay in 2019 in days. The answer was continuous days. So again, check this. All right. Remember how we talked about visualizing, like for example, the box plot. Isn't it a good way of visualizing the data? But sometimes visualizing is not enough. Sometimes, especially in biostats, we need a way to quantify this sort of descriptive analysis of the data. So one of the ways we can do that are with numerical summary measures. Now this is just, again, he's repeating for you sample and how we can make inference on the sample. Again, distributed statistics, we talked about them. Here's the bulk of the lecture. This lecture summarizes this slide summarizes the entire lecture. We have three things that tell us what is the center of the population, what is the center of a given data group. They are called mean, median, mode. They describe the central tendency of that data. There are two others, and not just two, there are actually many, many others that describe how variable it can be. One of them is range, one of them is standard deviation. And the reason he doesn't mention variance is because standard deviation is the same as variance. It's literally, they go hand in hand. One is just the squared of another. Okay? So later we'll talk about the normal distribution, but for now, this slide is practically nothing. Alright, this is also nothing. This is just, again, I'm telling you, data tends to cluster around the center of any, for example, given curve. The reason for this is because, honestly, the reason for this, we should be happy that this is the reason. There's no exact reason why, for example, we all tend to be for example, 6 feet tall, or why we all tend to be, for example, or why when they do a bell curve for their exam, why they want most people to be in the B's. Because generally, we're very similar to each other. It's only a few people who are, I don't want to say abnormal, but extreme. So generally speaking, even numbers follow this tendency. They have a tendency to be average. They have a tendency to be in the middle. Do you get this idea? Because a lot of us are just similar in our ways, despite having many differences between each other. So how do we find the center? And how do we quantify the center? We use mean, median, and mode. Now just to give you a quick understanding of them, mean is just the average. The average that you know from high school. If I have, for example, 10 plus 10 plus 10 plus 10 plus 10, 5 tens, you add them all together and divide by 50, what's going to be the average? 50 divided by 5, 10. Clear, right? This is mean. Median, let's use the same example. 10, 10, 10, 10, 10. Actually, no, this is a bad example. But you know the 10 in the middle, the third 10? That's our median. Because the median does not care what the number is. It just cares what is the position of that number. And it takes the number in the middle. Mode is the most commonly repeated value. Now, this example again is bad, but let's say there was 1, 10, 10, 10, 10, 10, 10, 10. The mode would be 10 because it's very commonly repeated. Okay. So, being able to generalize anything on a sample is how we know the specific details of a target population. We need to, for example, if I get a mean of a sample, not always, but most of the time, you can say that this mean of the sample is very similar to the mean of the population. Sometimes it doesn't work like that, and we'll talk about it in future lectures, but this is the core and the fundamental concept of statistics. We take a mean from a sample, and this mean should be very similar to the population mean. Mode, let's start with mode. It's the most frequently repeated data in a data set. Some data sets do not have a mode. For example, 1, 2, 3, 4, 5. Here there is no mode. Some data sets have one mode. For example, 1, 1, 1, 1, 3. 1 here is the mode. Some data sets have more than one mode. For example, and this is very important. 1, 1, 1, 2, 2, 2. What's the mode?
1.
From what? Okay. From what the definition says, there should not be a mode in this data set. From what the definition says. I'll go to the definition. The definition says that there should be a frequently repeating number, alhamdulillah, you guys hear that, Wallah, I feel it. I'm right under you. That's fine. Okay. What was I saying? Okay. A mode though. The reason there's no mode here is because the definition clearly says that it's the most frequently repeating number when compared to the other observations. What other observation are you comparing it to? Here the baseline is 3, so there's no mode. If I did this, and I said this is 0, then the mode is 1 and 2. Is this point very clear? Because from the definition, you can derive this, okay? Where is the definition? Somewhere here. Where is the definition? Yeah, it's this one, but say there's another one. Yeah, here it is. Other data sets may have more than one mode. This happens when a data set has 2 or more values of equal frequency, which is greater than that of any of the other values. If we just had this, it's not greater than any of the other values. This is not greater than any other values. We only have 3 and 3. It's greater than what else? Did you get this point? This is one of the tricks he could bring, although I hope he doesn't. Because this is, and honestly, this is a terrible question if he brings it. Because in his head, he could be assuming that, yeah, this is the mode is 3. However, the truth is there is no mode, according to the definition. These are just exercises, we're not going to waste time on them. Median, so now we're to median. Median is the 50th percentile, we talked about it, it is in the exact center, okay? How do we do it? There is a calculation way, but I implore you, don't get stuck in the trap of calculating and getting stuck and getting a mistake in the calculation or getting a bad calculator and you cannot do it. Just do it the way that I like to do it, where you just cross and cross, okay? The calculation side of it, if you want to do it, it's right here. We'll talk about this in a second. So if there is an even data set, you take the number of the position of it, you divide it by 2, and then you add it to the number ahead of it. So for example, this is kind of a bad formula, but it just means you take n over 2. So for example, here is 6, right? So n over 2 is let's say for example, like I don't know, like n over 2 is the number of values. So 6 over 2 equals 3rd. So the 3rd position, you take it, and then you take the position ahead of it. Notice, n over 2 plus 1. So just you take the position ahead of it. Take this. You take the average of them. What's the average of them? 1.5. 1.5. 1.5. You all agree, right? You're all with me, right?
Yeah.
Okay. Who said no?
لأنه even in the odd, I don't understand
Okay.
how can we relate them.
Okay. No, I'll say it like this. Let's say this is even. The best way is to compare them, and this is odd. Even are numbers like 2, you know this, right? And odd is like 1, 2, 1, 3, 5, 7, 9. So even, let's say 1, 2, 3, 4. Odd, let's say 1, 2, 3, 4, 5. You agree that this is odd and this is even, correct? When we try to find the median here, let's say we do cross, cross. Now what are you going to cross? You can't. If you cross and cross again, you're stuck with nothing. So when you're stuck with 2 values, which is usually the case with even, you take this value and this value. Now how do you find this value without doing the cross-cross method? They say just take all the values and divide them by 2. So I don't mean like add them all the values, I mean like count all the values. So if you count all the values, it's going to be 4 over 2, over 2 equals 2. So they're telling you find the second value, find the second value. 1, this is the first value, 2, this is the second value, this is the first value. Then they're telling you find the value ahead of it. N over 2 plus 1 is just the value ahead of it. I can prove it. It's 4 over 2 plus 1 equals, what is this? 2 plus 1, 3rd. The value ahead of it, the 3rd value. When we talk about odd, it doesn't matter if of taking 2 values, we just want to take the 1 value, which is the center. If you do the cross-cross method, there you go, value in the middle. What they suggest is n plus 1 over 2. And it's true, if you add 5 plus 1, which is 6, over 2, you'll get 3rd. Right? Where's the 3rd value here? 1, 2, 3. This is our 3rd value. And this is the median. So the reason there's a difference between even and odd is because with even, you'll get stuck in the middle. There's no number in the middle. With odd, it works in your favor and you get the number in the middle. Yeah, you can.
2 plus 3 divided by.
Yeah, this is when you pick this value and you pick this value, I don't mean you're stuck. I mean like when you cross and you cross, then you cross again, there's no value in the middle. So you have to pick these two values. So then what do you do to find the median? You take their average, which is 2.5. How do you find the average? Just 2 plus 3 over 2 equals 5 over 2 equals 2.5. Clear, right?
Yes.
So even, you take the two values. Odd, you take this value in the middle. You can use his way. You can use my way. But I'm worrying if you make a calculation mistake. I would also say know the formula just in case, because it might be a theory question, not a calculation question. They might tell you if we have an odd data set, what do we do? Do we take n plus 2 over 2 plus 1? You know, like he'll bring you these as choices. He won't bring you a data set, you know what I mean? He'll ask you what formula do you use. And so just memorize it just for your sake.
Just like you know that odd is this and even is this.
Yeah, odd you use. It makes sense. Odd, you're looking for one number. So it's going to be n plus 1 over 2. That's our number class. For even, it's going to be two numbers. Once it's going to be n over 2. The other one's going to be n over 2 plus 1. You just have to memorize that, unfortunately. Okay. So again, for an even, we're stuck here between two numbers. So then we take their average. For odd, we get the one number. So we're happy with it, right? Now, this is a great example. Notice how here, even though we have an outlier, our median is still 22. Further giving us an idea that if an outlier were present, the median will not change. Only the mean will change. When does the median change? It only changes very slightly, as if we put a new number there. You get what I'm saying? And instead of putting 388, it stays 38, but we add a new value. Now the median will be 23. Actually, no, not 23. It will be a mix of 22 and 23. You all agree with me, right?
Yes.
Good. We're done with those. Let's finally talk about mean. Okay, so mean is this. It's literally this. Okay, 2 plus 3 over the number of values. You just add all the values, divide them by how many there are. Now we didn't talk much about this. I'll just put them here for you. Wherever you can say a meaningful mean, you put the meaningful mean. For example, continuous discrete variables, you put the mean. Mean is not a good option for nominal data. I'll just write them here because it's important. Okay. If we have ordinal, if we have discrete and continuous, it's going to be mainly mean all three. It's going to be all three. So this is a general rule. It does not cover everything. This is a general rule that I want you guys to remember. And it makes sense. You don't even have to remember it. When we have nominal data, like male, female, like this and this, it doesn't make sense to give us a mean unless, notice here I'm putting it, unless we use the 0-1 rule, where we put 1 as the thing we're interested in looking for. So nominal, mode, and median are better than mean, unless if we have 0-1, the rule I told you about. You know the 0-1 thing that I talked about, right?
Yeah.
So did someone say no? No one said no. So 0-1. Ordinal is the same, because it's similar to, similar to nominal, it's just ordinal. The last one, discrete and continuous, usually since they're numbers, mean is very important here. Mean, median, and mode are all important, okay? So I hope you apply this during your exam problem. So this is median. I don't know if you guys know the summations, huh? So this thing. Like this, like, I don't know, like this. And then you have I equals something, and then you have basically like n up here, like xi, and then this. This thing means we're going to add all the values starting from here, whatever this number is, starting from 1 till here, whatever n is. Like n in this case is the number of data in our set. If we have 10, if we have 4, for example, it's going to be like this. 4. Here it means the first position, not 1 as in 1. You don't need to know this, you just should know any better. Just to get a feel for it, not just to be memorizing the actual summation. So it's going to be 1 plus 2 plus 3 plus 4 over n, which is 4. n. N, very important you remember that. N, not n minus 1. And this is where things get a bit more confusing. In nominal you mean? Ordinal? Nominal? I mean look, you can use ordinal cannot be 2. Let's say we have male, female. Let's say we have male, female. We have 3 males, male, and 2 females. Okay. This is nominal. But nominal is what I told you: binary or categorical. There's no order. Is there an order of male and female?
No.
There's no order, right? So it's nominal. Can you agree with me on that? Ordinal would be something like, for example, strongly agree, neutral, disagree. There's an order to it. A, B, C, D, F.
Why do you have to use the 0, 1 in the order?
When did I say this? I said this for nominal.
Is it the same?
Where?
Because over here you wrote ordinal the same as nominal.
Oh, okay. Same. What I mean by same is I mean median and mode. That's what I mean. I'm sorry. But it's nominal. And let me just continue it. Let's say male, I'll give them 1, and females I'll give them 0. So it's going to be 1, 1, 1, and then 0, 0. Okay? So it's going to be basically 1 plus 1 plus 1 plus 0 plus 0 over, how many are there? 5. So it's going to be 3 over 5 equals 60%. Does 60% make sense? It does make sense. 60%, the people are actually male in this study. Okay. And now we know summation, right? This is called summation. This is the principal concept of mean. And he's showing you how outliers can affect the mean because, again, the mean is a value that gets affected. Just one thing so you don't get confused. In biostats, they love using symbols to represent different things. You have to know what they mean. This is called mu. This is called x prime. This is called sigma, and this is called small s. Okay? Now, this means population mean. It's a parameter. Okay? This means sample mean. It's a statistic. This means standard deviation. In some, if it's s squared, it means variance, but just forget about it. Small s is usually standard deviation of a sample, so it is a statistic. And then we have sigma. It is a standard deviation of population, meaning it is going to be a parameter. So just again, this is standard deviation for this. This is population. This is sample. You have to remember, these are very crucial to understand a lot of the symbols that I'm putting on the PowerPoint and the board. So he's giving you an exercise of doing the mean. You don't need to do this, right? Just add all them together, divide them by how many there are, that's your mean. And here it is. Mean is important when you have dichotomous binary data, which is 0, 1. The exact same example I just showed you of male and female. So this is where he mentioned it. Again, he's showing you how he used it to get 20% males. Generally speaking, you need to know this rule. The median is the most preferred one. Okay? The median, generally, you prefer it more than the mean because it's less affected by outliers, and this makes sense, correct? So they love median more than mean, they love median more than mode, they love median everywhere, okay? And this is why he's showing you, notice how the mean here got affected by the outlier. However, when you take the median stayed the same. The mean is 21, the median is 21.5. The median is not affected by outliers. You're all okay with this, right? We talked about it extensively. Okay. The numerical value of the mode is closer to that of the mean and median, only in a normal distribution. So let me just explain it here. This is a normal distribution. I actually need space for this. Now, I don't like using the graph here because I'll show you in a second why. this graph in your head while I'm drawing it. You'll notice that the mode is shifting. Okay? That's not what's happening. I don't want you making this mistake. Here's the normal distribution. This is the mode here. Okay? I can't use M. Say O. Oh. So they're all on this point, mean, median, and mode. Okay? Now, how a positively skewed one would look like? It would look like this. That's kind of a bad drawing. So you notice the mode is still the mode. The only thing that happened is that there were some outliers here that pulled the curve positively, which is why we say it's positively skewed. Did this make sense? So the mean here would be somewhere here, the median would be here, and the mode would be here. Now why did the median get affected? Hold up, you said that outliers don't affect the median. They do affect the median, because here I'm telling you we added outliers. We added outliers that pulled the median. But notice they pulled the mean way more. I'll just make it again. Mode, mean, and then mean. Clear? What about if we add outliers this way? What's going to happen is it's going to be something like this. Here's going to be mode. Notice mode is going to be the same. Mode never changes. You're going to have median here, you're going to have mean here. This is going to be median, mean. Is this clear? They love asking this. I hope you understood it. We're done with mean, median, mode. These were measures of central tendency. Why numbers love to go in the middle? We need a way to quantify how well they go in the middle. We have mean, median, and mode to do that for us. For variability, we have something called range, and we have something called variance. Now range, it's absolutely meaningless. We don't really, I'll talk about what it is. It gives us nothing, basically. You take the first data set and the last, or not first data set, the first data within a set, and then the last data within a set. You minus them from each other. That's your range. So for example, let's just use this one. You take one, this is not the best example. Let's take 1, 20, 30, 40, and then 100. So our range here is going to be this value, the last value, minus the first value. So it's going to be 100 minus 1, 99. Now what does this 99 mean? It means that if you took the first value and the last value and you minus them, you get 99. Does that sound like something that's very meaningful? Absolutely meaningless. This is not a way to know variability, because look, we don't have any idea what's happening in the middle. We don't know if this is 20, 30, 40, or 20, 20, 20, or whatever. We don't know anything that's happening in the center. This is why range has limited usefulness. So look at quiz 1. This is quiz 1, and this is quiz 2. If you compare them, which one looks more spread out? Quiz 2, right? If you just took the range, you wouldn't know. You wouldn't know at all. So for that reason, they came up with something new called, again, this is range, all of it, everything that I said is the same as what I described. Instead, they came up with something called, we talked about all of this. We talked about this. I don't need to repeat it, right? This is everything that we talked about. Percentiles, box plots, range, we all talked about this. Sometimes, I will mention this is the last point about range. Sometimes instead of taking the first value and the last value, they calculate the 75th percentile and the 25th percentile. And they minus these from each other. This is why they call it interquartile what? Interquartile range. Range. So it's taking from one quartile to the other. This, again, I mean, it's good, it's fine. It's not going to get affected by outliers, right? Because if we have, like, say, 1 million here, this range would pick it up. But this range would not. So, yeah, range might help us, but still, we don't know what's happening between these values. So again, limited usefulness. Variance. Now, this is a beautiful story. Really nice story. I'm guessing the story was not told during the lecture. Or maybe it was told and no one gave it enough appreciation. Let me guess it was. I'm not going to guess what it was. Okay. Now we're stuck. Let's go back to when they were stuck. We have this thing called range. Some guy came to us and he told us, range is absolutely meaningless. There's no point in it. There's absolutely no point in it. Why did you even come up with it? So we were like, okay, relax, we'll come up with something new. How about we do this? How about, let's take a data set. Let's say, I want something with easy numbers. Let's take 10, 20, 30, 40, 50. We're going to stick with this for the remainder of the example, okay? Now, how would I know how far the data is getting spread? A good way to start, let's find the center and then see how far the points are going away from the center. Right? So we need to do each and every single point. So let's take the mean. Let's take the mean. So 30. It's going to be 30, right? You all agree with me? Does anyone not agree with me? So we'll just quickly check. It's 30, right? So mean equal, do I need to like calculate and everything? Well, we can all agree.
We can all agree.
All agree, right? So it's 30. Now here is the interesting part. If I take this point and minus it from the mean, this point, 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 minus it from the mean, and then what if I add all those points together?
0.
Well, it'll be 0, but wouldn't that be a good start? Because imagine it didn't give 0. Imagine it didn't give 0. Wouldn't that be a good start to finding out how variability works? Because you're literally looking at every point and how it's going away from the mean. You're checking every single point, checking how far it's away from the mean, right? So here's what they did. They added them, and everything, they saw what the variance that they came up with was going to be, and then they were like, okay, well, unfortunately, it became 0. So what do we do now? Well, in math, we have two different ways. Actually, I should show you why we're going to do this. If you minus this value from this value, how much are you going to get?
20.
Minus 20, right? Or if you minus the mean the opposite way, it's at the end of the day, one side will be the negative side, and this side will cancel the positive side, right? When these cancel each other, they're going to lead to 0. This is why you get 0, and it makes sense, because if this is the mean, and we're taking all the points here and minusing it from the mean, taking all the points here, minusing it from the mean, it shouldn't surprise you that this side will cancel this side. So it makes sense why you get 0. We're all okay with this, right? In math, we have two ways to make a negative number positive. We have absolute value. Absolute value is no joke. Absolute value is not like what we learned in high school where we just do negative 10 like this, then 10. This is baby absolute value. The real absolute value is you'd see it in some forms of advanced calculus where people would cry when they see these two lines. I cried when I saw these two lines. The point is, the other way is by squaring it. Squaring it is a beautiful way. It's not going to make you cry during the exam. Squaring it, when we square this number, whatever it is, it's going to be 400%. Whatever it is, it's going to be a positive number. So how about we find all these positive values, we find all these negative values, and then we make the negative values positive and then add them all together. They said we'll call this number that we find variance. And it should make sense to you. This number, it shows you how far each point is from the mean. So it's absolutely perfect. Wouldn't you agree? You all got this story. You all got this story. 1 second, because I need to specify this. However, when you go to the formula of variance, you notice something that is not explained in the slides. You notice this. N minus 1. I swear to God, whoever came up with N minus 1, he is the smartest person in the world. Why do you think there's N minus 1? Did he talk about it? Well, what did he say?
He said that it's, in the case that there's a mistake in our production, just to make sure that we're in the safe side.
That is one reason out of 3. That is correct. That is one reason out of 3. Did he talk about anything else?
No.
That is called, these are names from me. You're not going to find, if you search them online, you're not going to find names for this. But if you search online, you will find these 3 reasons. But there's no name for them. The first one is called the logical reason, which is what you just said. It corrects bias. And I'll explain why this happens. The first one is logical. The second one is mathematical. And the third one, I don't want to say it because it's going to might confuse everyone. Point is, let's talk about the mathematical one, okay? Didn't we, I wish I did not erase all this here, but didn't we calculate a mean? We calculated the mean, right? It was 10 plus 20 plus 30 plus 40 plus 50 over 5 equals 30, right? Now we're using this number in variance. Look, it's right there, x bar. We're using this number in variance. Okay? Is this clear? We're all agreeing that we're using this number in variance. So we are committing to the fact that this number should be 30 no matter what, right? Have you ever heard of something called degrees of freedom? I know this might seem like a lot, but believe me, you will thank me for this later. N minus 1, whatever this number down here is, it's always, n is the degrees of freedom. When we minus it by 1, it means we're losing 1 degree of freedom. Now, why are we losing 1 degree of freedom? The reason is, if this number was to change into anything, and this number was to change into anything, and this number changed into anything, and this one changed into anything, this cannot. This has to change to suit this number that we already committed on. An example, I want to change this. Anna, I want to change this, I want to put it 15. Okay, 50. This is going to be 40. This is going to be 30. This is going to be 20. This, I cannot change it. It will change itself to keep this mean 30. So it will change itself to become 10. Because this number I have no control over it. I have absolutely no control over it. So what are the degrees of freedom? We used to have 5, but now we're missing 1. So how much is it going to be? N minus 1, 5 minus 1, 4. Did everyone get this idea?
Yes. Can you repeat?
I'll repeat it. Didn't we say that we're using the mean in this equation? We're using the mean. Look, it's right here, x bar. We're using the mean. Okay? Since we're using the mean, we have committed to a value. خلاص, whatever this value is, we committed to it. In this case, it's 30, in this example. Since it's 30, خلاص, I cannot change this number when we're using variance. So my degrees of freedom, the number I'm dividing by, whenever it's n, this n represents the degrees of freedom. In this case, it has to be minus 1. Because since I'm committing to the fact that the mean has to be 30, all of these values can change except for 1. 1 will change by itself and I have no control over it. The better way to say it, I guess, is I can change all of these numbers except for 1. 1 will change itself to suit the mean. I can put all of these 1 million, 1 million, 1 million, 1 million. This one will turn into negative quadrillion just to compensate for the changes I caused. Did you get this idea?
Yeah.
The best way I can explain it, is that let's say 10 plus 20 plus 30 plus 40 plus 50. You want to find the mean. Will you divide by n minus 1 or only n? N, because we didn't commit to a mean. We divided by only n because we didn't commit to a mean. There's no number here. These numbers could be whatever the hell they want to be. However, since we didn't calculate the mean, we're dividing by n. N here is what? 5. So it's going to be 30. Did this gloss over your head, or should I repeat it, or what? It's good?
Question. And no matter what we change, the mean is going to be the same?
The mean is going to be the same. It's theoretical. Wait, it's theoretical. You're not going to change anything. But the idea is that if they were to be changed, there's one that you have no control over. It's not a degree of freedom. It's not something you can freely control. You have 4 that you can freely control, but since you committed to a mean of 30, this is not something you can control. You have 4 you can control. Yes?
Inner question, how would we know if we're using n minus 1 or just n?
Okay, if you're using variance,
Yeah.
since the mean is a part of it, you're using n minus 1.
N minus 1.
Variance, n minus 1.
Okay.
Mean, you're using just n. The reason I'm harping on this mathematical rule is because I want you to understand that we're using n minus 1 because we lost a degree of freedom. This is the mathematical rule. You got it?
Degree of freedom is like a safety rule. Just in case something changes, we still have this one thing that did not change.
Okay. Degree of freedom. Listen. I want to. You know what degree of freedom is? It is how many values you need. This is the actual mathematical definition of it. I don't want to. There's a lot of questions about this. I don't want to further confuse you, but it is how many values you need to be able to solve the equation. Okay? So here, 10 plus 20 plus 30 plus 40 plus x equals 30. Over whatever value, let's say 5. how many values did you need? You needed 1, 2, 3, 4, 5. Did you get it? Guys, just forget it. I remember, I swear to God, the first time I explained this concept of n-1 to them, to the batch before, they all said, and as soon as I said it, they go, oh, and then they started clapping. You know, why? I think if I create the cure to cancer, I think there's nothing, you guys are just going to poker face me. Why? Okay, the second reason. This is going to, again, confuse you. I want to explain what he said about the logical reason of n-1. It's going to be 5 minutes, I promise. And it's going to hopefully make you better. If you don't understand it, it's fine. It's absolutely fine. If you did, it's all the better. And we're going to cover it later. Okay? So here you go. If we divide by a smaller number, do we get the product? Will it be a bigger number or a smaller number?
Bigger number.
Bigger number, right? Okay. Remember when he said it compensates for bias? It compensates for something called bias or something like that? If we divide it by n, this variance will be a low number. If we divide it by n-1, it will then be
Higher number.
higher number. If we have, for example, something like this, and we have something like this, being more a variable, being wider, you're more likely to include more of the data set. You're more likely not to miss anything. You're more likely not to have any bias. Did this make sense?
Yes.
Okay, I'm happy. Awesome. You all understand this, right? Do you want me to repeat the mathematical logic behind n-1 again? I honestly do not mind repeating it. This one? This one. Okay. Look. Which one is which one is wider? This one or this one?
The one with the bottom.
Since it's wider, it's more likely to contain the results we need. Just memorize it like this for now. This is a topic for the lecture after your midterm. But just understand it now, because if he said that, Dr. Hassan told you that the logical reason, the compensates bias, then I think you have to know. Since it's wider, it's more likely to have the results we need. Let's say, I'll just give you an example. Let's say we have this value here. We have this value right here. Okay? This graph won't pick it up. This graph, the small one, will. So notice how when dividing by n-1, we got a bigger, wider graph. It was able to catch this result. Now sometimes it doesn't make a difference. The result could be here and they both catch it. But and if you do the result, if you do the study 1,000, million, 1,000 times, this one will catch more than this one. You agree with me?
Yeah.
Oh, this is n-1. Mathematical one? Oh boy. Okay. Okay. Remember when we talked about how we're gonna first start the story? We talked about range and how it's not gonna help us. And then we said, okay, how about we take the difference from each point to the mean? We saw the difference from each point to the mean, then we squared the values that were negative. Now, since we did this technique, it all started with what? Calculating the mean. So we agreed, for example, 10, 20, 30, oh my goodness, 40, 50. When we calculate the mean, it's going to be 30. Now we can agree that khalas, this value is this value. It's not going to change, right? Now we're going to put this value in this formula. Okay? We get whatever value. We get, for example, 26 centimeters squared. This is the variance. We got this value by doing the formula and then dividing by n-1. The reason we're dividing by n-1 is because this mean that we calculated by adding all the numbers and then dividing by 5, I could change this value, this value, this value, and this value. But this value is not under my control. It will change itself to keep this mean 30. Which is why we're not dividing by n, because we don't have 5 degrees of freedom. We only have 4, which are this, and this. Or it could be, I'm not saying this one exactly. It could be all of these. I'm missing this one. It could be all of these, but the 30. The idea is that one of them I can't control. Clear?
Yeah.
This is variance. Yes, yes. You can't clap after I say that you're supposed to clap. This doesn't work. Is there a question? I heard someone ask me. It's a good thing I don't know the reason. Other reasons, forget about it. So this is variance, right? And you should be able to know how to calculate it. In this case, they just did it instantly. This is the example. Should we waste time on it?
No.
Oh, you just take the difference from each one, from the mean, then you square the negative values. You square all the values, but then only the negative ones will become positive. You add them all together, you will get variance. Now how do you get standard deviation? You just do the square root of that number. Now it's very important. People prefer, this might be a question, people prefer standard deviation more than variance, which is like capital S. Let me just put that. People like small s more than s squared. Why? It's mentioned in the slides. It's really important because here the unit will be, for example, centimeter squared or inch squared or millimeter mercury squared. Standard deviation will just be centimeter. So people prefer the unit to be similar to what the mean is. The mean is usually going to be also centimeter. It won't be squared. You get it? So here, this will be squared. To find the standard deviation, you just have to square root this. You'll get this. And this we prefer it because of the units. So we covered the hefty amount of the slides. This is just an exercise you can do at home. You just add all the squared things, and then you get the sum. You take the square root of that, and then cos. That's your standard deviation. We usually prefer because the units of the same as units of the data set in centimeters. Standard deviation is just the square root of it. It's in the same units of measurements as mean. And comparing two groups, the larger the s. Yeah, this is important. The larger the s, the more the standard deviation, the bigger and wider the actual graph is. Yes.
Susan, can you please name the third reason for n-1? Okay, just the name.
Oh. How about after the lecture? After the lecture, I'll give it to you. Okay. Coefficient of variation. Coefficient of variation, you just memorize it. It's going to be S, standard deviation, over the mean. The purpose of it is just to compare one set's variability to another. This is the only thing you need to know about. It's just a coefficient that helps you understand whether one data set is more variable or less variable than the other. It has no units, and you can probably guess why, because standard deviation has, for example, centimeters, and then the mean also has centimeters. So when you divide them over each other, you lose the centimeters, you have no units. Finally, group data. There are two more concepts after this. But group data, instead of saying, for example, 1, 1, 1, 0, 0, 0, we say 3 times 1 plus 0 times 3. This is just grouping them based on how many there are. This is just basic math. You all get it, right?
Yes.
In median, we talked about this in a skewed distribution. The mean will go furthest away. The median will be in the center. The mode will not change. Again, right skewed is the same as positively skewed. Left skewed same as negatively skewed. You all understand this? This is called bimodal distribution. The reason is because it has two modes. And here, which one is more variable?
The blue one.
The blue one, exactly. So do you expect it to have a higher standard deviation or a lower standard deviation?
Higher.
Higher standard deviation. It's more variable. I think we're pretty much done. We just have two last rules. Something called the empirical rule and something called Chebyshev's inequality. Now, the empirical rule, it is for, I don't want to use political terms. You ever heard of liberal and conservative? Just to make it easy, this is not how you're supposed to eat. You're not supposed to drag politics into it, but liberals are more likely to they take things ideal, make things ideal. Okay? Conservatives, they're not as ideal. This is the only thing I want to talk about it so far. Conservatives preserve much less of the data than liberals. From its name, it's conservative. It takes only a small amount of the data. So now, when would this be useful? With the empirical rule, if we have a perfectly normal distribution, it's good to apply this rule. And I'll show you why. There's no normal rule. Okay. Here. Look here. This is our normal distribution. This right here. Okay? When it's perfectly normal, we can make assumptions about this curve that the empirical rule helps us. One standard deviation, if we see how much this covers, it covers around 68%. Okay? 2 standard deviations, if we see the whole value, it will be 95%. We take 3 standard deviations, this will be 99%. The point is, when it's perfectly normal, we can make these assumptions. What if it's not normal? We have something more conservative, something that does not make these radical assumptions. Something that will conserve some data if it's skewed or unequal or bimodal and so on. This is called Chebyshev's inequality. The formula is just 1 minus 1 over k squared, where k cannot be 1, or k cannot be 0, because then it would just be 1 over 0, it doesn't work. Even it cannot be 1, because then 1 minus 1 would be 0. It has to be 2 or more. Okay, and it's only integers. So you calculate it. You don't have to memorize the numbers. If you just remember the formula, just start plugging in numbers during the exam. You'll get the exact values. But the point is, let's say we have this sort of figure, and let's say the mode was here. We would rather like using Chebyshev's inequality than the empirical rule, because we cannot make assumption that this is 1 standard deviation, 1 standard deviation, and we can't say this is 68%. Instead, we use Chebyshev's inequality, we count the standard deviation, and then this would include 75%. Sorry, if this is 1 standard deviation, it doesn't work. 2 standard deviations would include 75%. You get it. This is 2 standard deviations. If we assume this is a normal distribution, it would already be at 95%. So notice how with Chebyshev's inequality, the same standard deviation. These are both 2 standard deviations. Notice how with Chebyshev's, it's a lot less. Clear?
Yeah.
This is all you need to know about Chebyshev's and empirical rule. Any questions? One standard deviation, you'll get a 0, and 0 doesn't make sense. So there's no 1. You start from 2, as you mentioned here. Let k equal 2. I don't think the rule is here. Yeah, note only k greater than 1 provides useful information, because 0 you can't put 1 over 0, it'll be undefined. So 1 will be a 0. Clear? Yes.
Is k the same thing about like 1 standard deviation?
Yeah, k represents the standard deviations. K, if you say 1 standard deviation doesn't make sense, but it doesn't make sense because it's going to be 0. But if you say k equals 2, you mean 2 standard deviations. So k represents the number of standard deviations. All good? Yes.
How do we know what's K? How do we find K?
No, k is the number of standard. He'll tell you. Find 2 standard deviations according to Chebyshev's inequality. So k here automatically is 2. K is the number of standard deviations. Yes.
In what case would you get a distribution like that?
Well, in all cases of life. Sani, look, I'll talk about this.
Because most of the cases that we saw in class, they had a normal distribution.
Yes.
So we barely saw that kind of.
Exactly. You never, whenever teaching biostats, they never use this.
Yeah.
But this is what you see in real life. So the only application for Chebyshev's inequality is this. So we're never going to talk about Chebyshev's inequality. From this point onward, we're always going to assume we're working with a normal distribution. Clear? Anything else?
So this Chebyshev's inequality is best when the distributions are optimal.
Yeah, when the distribution is skewed, bimodal, just looking weird or funky or something, then we use Chebyshev's inequality. Clear? Would you like a break before we go to the next lecture? What's the time? Almost. Yeah, we're actually ahead. We're ahead 8 minutes.